into two sets of fields, F and E. The fields in the second relation can be partitioned into two sets of fields, G and F. And then the third relation, the result relation, can be partitioned into the combination of all three of those things, E, F, and G. Okay? And so that's what that's saying is that the fields that you get when you do a natural join can have some overlap, and that the result relationship has all the fields that are in both sets, including the overlap. Okay? And that is interesting because traditionally, row-type systems have let us only kind of say has and lacks kind of constraints. I have everything that's in this other row type, or I lack everything that's in that row. It turns out that this one kind of constraint that Paul came up with, it lets us kind of subsume that notion because I'm blaming Paul, yes.
It's his fault.
It is his fault. We have this weird kind of constraint. It's actually really kind of a genius. I'm really happy with it when it works. The interesting part is you can model has and lacks constraints by just using this with an existential context. So you can say like, C has F when there exists a G such that C can be partitioned into G and F. All right. And we can say that F lacks a G when we can partition C, that when there exists a C that we can partition into G and F. So we can talk about has and lacks constraints kind of implicitly just by this ability to partition. And so, when we partition, these wind up being disjoint sets of fields that together match up to the original info.
That's the Harper kind of, I forget the name, but the strict extension or whatever.
Yeah, this was our, we took the, Benjamin Pierce and Bob Harper went off and wrote a type system. It was kind of like this. But they didn't quite have the partitioning notion that we do.
Yeah,
and they conjectured in there that you could do type inference for it. But they didn't provide an algorithm. And we tried to come up with one. And eventually we just came up with a bunch of hacks that seemed to work. So in practice we had this huge table of rules that seems to be confluent and terminating for all the examples we can come up with. Many of the examples,
I don't know if you can say that it seems that way.
Yeah, okay. It works pretty well. There's a few corner cases, I'll freely admit. Some places where you have to use $sign rather than dot to avoid accumulating just this ever-growing set of logical consequences.
Yeah. Theoretically, it seems like they're confluent and terminating.
And there may be bugs either in the semantics that we have or in our implementation. At some point in time, somebody might care to actually go through and prove it. So just so we're clear, that's an actual Greek row, and so we use that for our row types, which are. So if you look at why you're seeing P's, huh?
It's not their joke. It's Mitch or
it wasn't. I don't remember where we started from.
Row types. The metasyntactic variable was a row. I think it's Mitch's.
Yeah, it sounds about right. So we started with that, and then I said, how hard can row types be? And Brunar implemented the actual interpreter for it and completely ignored the types for all the row type stuff at the time.
It was hard.
And then Dan actually managed to get something that worked.
Can't think of any other type classes.
So, for the most part, the kind system is very much like GHCs today. It has polykines, which is actually kind of nice. We have.
There we go.
It does tab completion and stuff in the REPL, so it's just like JLine will look at the current environment. Figure out what you fill in. So
Gamma is contexts.
Yes. So gamma is constraint.
Yeah.
So num is a class that takes an argument of kind stuff. And it's a neat little toy. I know Josh and Dan had some example they've been working up with, like actually using this to talk to a database.
Yeah, I can
access. Oh, right.
Okay.
We should fix that.
Yes.
Okay, so now we can see, so some interesting stuff. There are first-class field witnesses for each of these things. So person, name is a field, and it has row type, person name, and the element type is string. So those exist for all of these, and they're used with some relational combinators when you want to refer to specific columns. And you can like aggregate them into rows to refer to multiple columns at the same time and stuff like that. The other type of database interactivity is table declarations. So in this database that I'm going to be using, there are 5 tables. There's person, which has person name, age, and a ID. Company has a company name and an ID. And then there's a relation that associates persons with the company that they work for. There is a table of foods, which has an ID and a name, and a table that associates people with foods that they like. This just lives in a SQLite database in that file, testDB. So to interact with the testDB, you create like this is just a connection to a database, and then run will allow us to get the records out of a so it takes a relation and it scans all the rows into a vector and gives it to you in IO, right? I have some helper functions that will print each record on a single line, because otherwise it comes out as a horrible mess. You just have a vector of tuples. So, let's see here. So this is a relational expression, people. The syntax here is ** is join, and hash is project out columns from the row here. So this joins person, company, and person, company to associate people with their company, and then projects out the name, age, and company name. So we should be able to scan out people.
I assume it doesn't matter what order you start things together.
It's a natural join.
Right.
Well,
it doesn't matter for results. It might matter for whether you're, whether it will finish type checking and stuff like that. So we scan out and we see a bunch of people. There's Simon Marlowe at Facebook, me, Josh and Ed at McGraw Hill Financial, and Dan Peebles at Bridgewater. I kind of thought that, never mind. Okay, so we can also, there's this, let's see here. So we have a combinator. So this right here, first by selects the, well, by some ordering it selects the first row. And in here we're ordering by age. So we get the oldest person and the youngest person. And let's see, here we make a table of the oldest and youngest persons. And we have Simon Marlowe is 27 and Ed Kmet is 60.
ouch.
Okay. Let's see. So I have that foods and people table, so we can ask what. Let's see. Oh, another thing. So this AND operator we have here. This right here is syntax for a single row, and if you join with a single row, the value is kind of like a filter. So people end up doing that a lot. So I'm filtering this person likes foods thing with to get only Dan Peoples foods, and then I can scan out Dan foods. and he likes katsumarzu, Kobe beef, and spaghetti. And then there's another person in the database who I know likes weird foods, apparently. Let's see. Scan out. So he likes Hakarl?
Okay.
Oh, wow. He likes ice cream and skyr.
Could you go back to the...
Really, ice cream.
It's pretty weird.
How could you eat that?
I don't know.
You described the ampersand as a join, but it's actually with a row, not a table.
Yes, this is, if you looked at the definition of this, it would be star, relation, something like that. So relation takes a list of tuples and builds a relation out of it. And then, yeah, this is a special, case for one row. People use it a lot because I think it used to be a lot more convenient than filtering. And then we have like a whole optimizer thing that will find stuff like this and turn it into a filter if you're, joining with a single known row and stuff like that.
So it's effectively a select.
Yeah, basically
Yes.
it's the where clause in the
So it's a
select.
select and then it's implemented in terms of a join and then you optimize it back to a select.
Yes.
Okay.
Yes. There's also a filter somewhere, I think, but I couldn't find it. 'Cause I don't like to program in this. I just write the language. And like my final example, I have the MHF dinner party where I'm joining all of the tables together. So that associates people with their favorite, or with the foods that they like and their companies, and then I'm filtering down for only people who work at McGraw-Hill Financial, and I'm projecting out the food name, and I can scan out with okay, so this is a lambda expression, there's no backslash, and this is record projection, so I'm projecting out the food name column of the record in each of these things. This is a slightly different combinator than I've been using. And I can see that if we have such a dinner party, we should get chili, ice cream, Kobe beef, pickles, skyr, and spaghetti. So I think that's the end of my demo, unless you have questions about other stuff.
You mentioned having an optimizer. How much planning are you doing and how much are you dumping on the underlying database?
It's mostly dumped on the underlying database. We think about what we do. I mean, we do a fair amount of stuff, but it's mostly like if you just put these together naively, you get like super nested selects and stuff like that. And at some point we were like overflowing the limits on like MySQL's allowed expression depth and stuff. So it does a lot of coalescing of stuff into things that the database will at least accept and can land on and stuff like that.
And we also do some things like we'll build like in-memory expressions. We'll go back and forth with the database if we absolutely have to, and build temp tables and do things like that in order to
Oh yeah.
realize.
One thing I didn't include in my demo is so we have let expressions that you can do in a relation. So that will like so this is like a context in which you can refer to this table by like an extra identifier, and this will like populate a temp table in the database and then do all the joins against the temp table. So you can sort of express that.
So if you have to do some like streaming in-memory nonsense to work out some sliding window calculation that would be awful in SQL, you can move it over, do the work, send it back.
Do you have any examples written by users?
No.
Because what's super exciting is that you stripped a bunch of people into using it.
The problem is that a lot of that
a
stuff
bunch of
is-
type nerds going
The
off
problem is-
implementing Haskell with row types is awesome, but you tricked
Yeah.
normal people
Yes.
into using this, and I would love to see what
So part of the problem is that a lot of that stuff that does that is like the reporting framework and stuff like that that we have in open source.
That's all
Right,
like
so
that's proprietary
I'm just
stuff.
saying, as a curiosity, I would be really excited to know what Excel jockeys have thrown this into.
We actually, I think like 50% of the people writing this stuff are like kind of functional guys that need
Who's Alexi?
Yeah,
Who's
there's
done
Alexi.
all of The, turning the old
Matt Morton and-
into.
Yeah, Matt had a hard time with
Yeah.
He was doing like UI stuff.
Yeah.
Yeah, he was both suffering through like how to learn this little language, but also how to talk to Java and all that other stuff from it, and we kept changing the language out underneath it.
Yeah.
So
There's an FFI to Java. I think Josh is gonna show you some of that more because he has it integrated with Minecraft already.
As you should.
yeah.
Is there documentation online?
No.
Not really.
You can go to erminelanguage.github.com/ermine, and there's at least some haddocks that got generated for the new Haskell-based compiler of it.
Oh, right.
But-
That's another thing we haven't mentioned. So all this stuff that I'm running here is written in Scala, but it has quite a few problems. So we decided like a kind of a major rewrite was in order, and instead of writing, we decided that we were going to separate it out into like a compiler that spits out core, and then you can run the core on anything, right? So we're rewriting the compiler portion in Haskell, and then we'll have like runtime systems on in Scala, and who knows what else.
So we got
Java.
senior management to finally sign off on open sourcing it, like Monday.
Yeah.
So we released it Monday because before they could change their mind. And so we said, here's the Haskell compiler that we have, and we know it doesn't work. And then Josh heroically worked on getting the old Scala compiler down to a state that we could release, and then Josh and Dan managed to get like a larger subset of it that actually had all the data stuff that you just saw.
Can't help a lot getting it done first.
Yeah, so there's a completely unmaintained Scala version that you can play with like this, and there's a Haskell version that doesn't have everything done yet, but will in the future.
And it's way sexier.
Yeah.
And it, if for those of you who know my random libraries, it uses bound for all of its name capture and stuff like that. So it's actually
There's lots of lens stuff as
Yeah.
well.
Really?
Yeah.
yeah. So it's the start of a model of the way I think a compiler should be written.
Yes.
I can't wait to see.
There's also
No, just 6 months from now,
yeah. If you want to
when the back end happens.
Yeah.
if you want to compare
6 months
bound
from
in
now,
Scala
Ermine
versus
language
bound in
will
Haskell.
Something like that.
Yeah.
If you want to compare bound in Scala versus bound in Haskell, there's all the relational theory stuff is implemented in a custom bound in Scala thing. So
There's also the toy implementation of the core interpreter that Josh has that should be using bound if I recall, right?
yes.
So there's two implementations of bound floating around in Scala to
Yeah,
compare with
that one
Haskell.
actually uses Runar's Scala bound library.
Straightforward.
Did you guys play with the relational division?
The what?
The relational division operator?
I don't know what that is, so.
What is that?
It's you make sure that for any row, every other row in another table matches that. So like for every person, they all eat ice cream.
Okay, no, we didn't actually implement that. Is there a nice clean translation to standard SQL?
Yeah.
All right, then maybe we can
play around with it. We can.
There's power slots.
Oh, yeah.
So there's a few other interesting things I think about the guts of this. Like the I/O implementation is actually remarkably.
Probably go look at it now.
Yeah. So at some point in time, I wrote a blog post on how to do I/O for free. No, it's just I/O. I/O.e down at the bottom. And so what we do is we actually have a strictly pure programming language. The way that it communicates to the outside world is that we have we have like a runtime system that can ask our language to compute something. And we can just eval, right? And then the way that we model I/O
I don't think
is
so. I think it's in IO. No, it's not
that's a
there.
run I/O, which gives you the method to extract the contents of I/O. So this is like the contents of I/O. So an I/O action is a continuation that is a function that will, given a continuation that knows how to do something with the actual answer it's going to finally compute, and a continuation that says, if you know how to handle the output, that says, given an FFI I, something that knows how to run some external calculation and gives me back an I, and a pair of operations of what to do with the result of it, and what to do in the case that it actually doesn't give me back a result, it throws in Java, and something to do if we have to throw in general, I'll give you an R. Ugh. Okay, but the nice thing is that what's happening is the external runtime system is able to ask the language to compute some FFI calculation for it. So it's asking it repeatedly to go give me something to do next. So we have a cooperative coroutine.
Stream thing from Haskell 1.3 through monads and ST.
Sort of, yeah. It's a slightly nicer version of that, in that what's happening is the language itself remains entirely pure, but the I/O subsystem is basically just a cooperative coroutine with the runtime system. And so the runtime system is just basically asking it, okay, what do you want me to do next? Okay, here's the answer to that. What does that compute? So it's just repeated evaling from the system.
I'm not sure where IO is defined. It's not in here.
The I/O monad itself? I/O itself is defined in foreign. Or in lib, it's actually built in.
Oh, okay.
Because it needs to be in built-in because it's
Because we generate it from.
yeah, when you use the foreign import machinery. You could. I don't. we never bothered to implement it.
What?
Fork. Yes. We don't currently actually have a
You
fork.
can't fork in Java.
Yes, we don't have a proper, we don't have a, like a Haskell fork OS fork,
Oh.
fork kind of thing. We don't actually have a thing that spins off a second RTS thread to interact with the system. It actually would be remarkably simple to implement. And then the other thing is the existing Scala implementation doesn't actually have proper type classes, so we wind up actually passing around explicit dictionaries to some of the methods that we have to
Yeah,
work
that's
with.
one of the things we're doing in the new Haskell version. Is
The new Haskell version is built from the ground up to have type class support and to properly desugar from a term language using the types into a core, and
Yeah.
What was
then the
num?
core is small.
What?
What was num?
That is a built-in. So this has all the machinery for doing the constraint solving, and you can put anything in there as long as it's implemented by a magic Scala function that will
Interrogate the objects and figure
inspect
out
the types of the things and do the right thing.
So what happens is we have type class solving, but we don't actually have dictionary plumbing. So type classes have no substance to them. They're purely informative. It's
So plus, so that is a Scala function that will call plus.
and then we have a number of built-in num instances. It's a
then-
horrible
yeah.
hack.
And then the num makes sure that you only add doubles to doubles and stuff like that.
How tightly could you integrate this with actual Haskell? You're describing core.
So the main thing that's different about us and Haskell is that we have this pluggable system for dealing with row types. That is like the one kind of irreconcilable difference, plus a bunch of random syntactic crap to make the relational stuff nicer. In theory, if like the GHC compiler plugin support got to the point where we could talk about, let's hook into type class resolution, maybe we could actually make, plug in our row type solver into, say, GHC and just say GHC is Ermine, and we're done. We do some other fiddly little things like prefix and postfix operators and stuff like that.
Right.
They're trivial. In general,
We have an example of that.
the only real reason that we kind of went off and did our own thing was because we had to live on the JVM, because we had to talk to swing and all these other things. What's an operator that's good to play with?
I don't know. I don't know what we have that's a prefix or postfix operator.
Paul, you remember?
Well, there's.
He's
there's
flushed it all.
Right, like minus isn't, oh, apparently,
What happened to minus?
like, okay, I guess there is no prefix minus.
No, we wound up removing it for a reason. I don't remember what it was.
All right.
Like, I guess, could you turn this into like heavy quasi-chord?
You might. It'd be really heavy. And again, the problem is we had to run in the JVM, so.
You have different constraints.
Yeah.
Not having those constraints, I still like your logic. So I'm trying to figure out how I can get this. Okay, clearly this is how somebody should be accessing their database from your Haskell web applications, right? So-
You know, I mean, there's parts of it that I really like in that regard. Are you just defining one?
2014.
Clearly, heavy quasi-quoters aren't going to stop the yes out people.
Oh, you have to define those together in a block. You have to do the.
That was a block.
You had two statements. You had prefix something, and then that was a continuation.
It's
You're right.
line continuation, yeah.
You have to put the caret with the prefix, and you got to define it. Can't remember how to do this. We don't do this very often.
Ah.
There you go.
Oh,
There you go. There's a prefix operator. So it's just like infix and postfix statements. It's just, it's a crappy little shunting error parser, and so we can do prefix and postfix operator. I don't know. Do you want to pull up like parse study, and then I'll hand it over to Josh? That might be an example of like something that actually does some non-trivial like interaction. Like it shows some use of the
it's a
foreign machinery
thing.
Yeah. So, for instance, like Java has a whole bunch of stuff for parsing numbers, and we didn't want to write it ourselves. So when I got bored and like threw together what is more or less our prelude, I stayed up and like beat on adding a bunch of stuff to it that we didn't necessarily. But so one of the things that I added was just borrowing all the parse int machinery from Java. And this at least will showcase a little bit of like how you can talk to a foreign function interface, to the foreign function interface. So we have private is our scoping system right now, just because it was the smallest syntactic change that we can make to it.
There's no export lists. You just have things that are private instead.
What's that?
Can you point to that one?
Which
Can you
one?
point to that one?
Oh, this screen? Sure. Oh, because you got your. Okay. So what we can do is we can say we want to make up a new. So we had throwable. It was in scope. It was something we imported above, just because we needed it for I/O, and so it's a fairly standard type. And then what we wanted to do was we need in order to talk to like the parse functions. Like if you go to like call Java lang float parse float, it will throw a number format exception if you give it a badly formatted number. And to Ermine, I actually want to expose this as a pure function. So I don't want to actually expose this as an I/O action. I actually want to expose it as what we call an FFI action, which was actually originally how we implemented I/O, is we had I/O just invoke these FFI actions with a wrapper, and then we made the implementation of foreign functions smart enough to do I/O directly. So here what we do is when we parse it, we're going to get string int to an FFI int. And if you actually go into the type of FFI, you can say unsafely perform an FFI action, and that's going to give me basically an either of the throwable or the actual result. Now we want to work with number format exceptions, so we can make up a foreign data type for number format exception. That will just be a Java object type, a Java type. And then we can say that there's a subtyping relationship between number format exception and throwable. So technically there's a couple other layers in the middle. We can skip right over them. In this case, we're just going to say number format exception should look like it's a constructor for the throwable data type. So if you pattern match on number format exception, what you're going to do is you're getting the number. This is now a number format exception that you could then go through and pass on to something else. You can work with the Java object directly. So our solution to the subtyping problem is to completely ignore like any sort of implicit subtyping relations in our Haskell-like language, and instead just provide you with these kind of virtual constructors that reify
It's a lot
the
like new
subtyping
types.
relationships.
It's a lot like new types.
Yeah, so we basically, these are zero cost. They're like new type overhead. It's basically an is instance of check to do the match internally. And so basically here, what we're going to do is we're going to run this thing as an unsafe FFI action, get a number format exception, and just give that back to you as nothing. If we get another exception, we're just going to re-raise it. We're actually going to throw it. It becomes a bottom. And anything else just becomes a pure result on the right. And so what happens is now we can take these slightly exception-oriented APIs and expose a pure-looking API to Ermine.
Do you have a method?
Yes.
Yes, we have foreign functions, foreign methods, subtypes, div types.
So function means static method and
Yes.
method
Exactly.
means-
This is a static method in the Java lang integer class. And you can import these as either pure functions, as FFI functions if you want to be able to catch if you want to be able to manipulate the throwable values that they give back directly, or IO actions so that you can run them with, in longer chains of things. And with that, I think I should probably hand over to Josh because I.
Oh, do you do tail calls on your own stuff?
We have so at first no, but it became a problem. So I rewrote the interpreter to just run in like one tail recursive loop in Scala, and it can actually optimize that into an actual loop. So it runs in a loop and doesn't use much Java stack most of the time.
And you can put in Java calls as well?
I don't think so.
Okay, so I can still run my stack sneakily by...
Yeah,
If you move back and forth between Java and Ermine,
yeah.
like if you call Java functions that will internally call Ermine functions back,
Okay.
then you could in theory build them.
All right, I'm going to show this ridiculous stuff I've been doing. Never mind. I've put in only a couple of hours on this, but it's pretty fun. I started on Monday night, and I just couldn't stop. So is there anyone here who doesn't know what Minecraft is? No, okay, that's cool.
Is this a Minecraft plugin?
Yeah. So I'm going to show Ermine running inside of Minecraft.
You now have Erminecraft.
A long time ago.
Blocks that you can...
What's that?
You have new blocks for the different syntactic blocks.
I'll show you exactly what I have. All right, a while back I wrote a bunch of Scala stuff for easily writing plugins, and then I used that to just write this little plugin that allows me to do two things right now. One is I can run some Ermine code, so at the command prompt in the game I say run Ermine, and then I give a module and a function and some arguments to it, and it just runs it. And I'll show you that. And then the next one, which I just implemented like sitting over in that seat and back against the wall, is register Ermine listener. Which allows you to just register a listener to events that happen in the Minecraft world, and then shit happens. And it actually works, so that's cool.
Did you use this to say publish everything you do in Minecraft to your Facebook wall or something like that?
Well, sure, I guess. Yeah.
Only use your power for good.
All right. So when I run this plugin, it's reading all of my Ermine stuff out of this resources directory, and I have like three or four little files in there. But I'll show it working first, and then we'll talk about it a little bit. So I'm going to run my server now, and I'm going to hop up on it. Yeah. So when I start my Minecraft server, the Ermine session boots up. So I'm going to wait for it until I I'll show you. So I have this tiny little module here. Has two functions in it, hello and goodbye. They take the player as the first argument, and then the rest of the arguments that you type into, you'll see me type them in. And they actually don't do anything with the arguments. It just says hello back and see ya. And I'll do that really quick. Oops. So here I am in my world, and I can say run some Ermine. The module is hello, and I can say hello, and I'll just say hello back. I can say goodbye, and it says see ya. That's not very special at all, but I can come over here and say, I can change this, and we'll pick that up as I'm hanging out in the game, so I can do it again, and it recompiles it, and yeah, that all just works. So that's pretty cool. So you can just change code and add new modules and just have them run. And if you've ever written a Minecraft plugin, especially in Java, it's a whole shit ton of work to get this jar together with the plugin.yaml and the resources directory, and just all sorts of stuff. And once again, I just started this a couple days ago, but I think it's an awesome way to go because you can just drop in an Ermine file and have all new functionality immediately without having to do anything. All right, then I have this zap guy, which is going to call this zap function, which is in this Minecraft module that I have built, and that's where a lot of the calls to the JVM are. Zap, come on, what the hell is going on? All right, zap is down here. It's just a function so this is module Minecraft. Can everyone read this? Is it big enough?
Make it a little bigger.
There we go.
Good.
All right, let's you hide this thing. Hide this. All right, so this is module Minecraft. I bring in a bunch of data, so there's a class player, and I bring that in, and there's some functions on it, methods like you asked about before. There's send a message. That's actually how I implemented the hello, is by calling send message on player with just a string. Actually kill this because it's eating my CPU. I'll bring it back in a minute. This is get world and get location, but there's a whole bunch more functions that I haven't added yet. And I've been toying with the idea of writing a generator for these things because there's hundreds of functions, and I really would want them all. So I'm just having to type them in by hand for now. All right, so Zap. Zap is implemented. The way that Zap works is you have to get you have to say, let's see, like world.strike lightning at some location, I think. I can actually look it up. World strike lightning. If you have a world, you can call strike lightning at a particular location. So I had to expose get world on player. So all you have is the player when you type in your command. So get that's just up here. Get world, that gives you back a world, or else the IO world, because you can change worlds. Get location. There's a get location for a player, which is an IO location, obviously, because this location can change. And finally, strike lightning is on world here, and that gives me back, an IO action, and I unsafe it here, which is not amazing. that's the only place I have to do it. And I guess I can do it inside of inside of the Scala code. Just assume that any command is going to give me back some I/O action.
Yeah, you could move the I/O there, and then it would just be a little more work to.
Not have to do it in the Ermine code itself. All right, so let me zap myself. So zap actually, all right, just right now it's just zapping the player that puts in the command. I'm not actually using the arguments. I should be like taking the first thing out of the argument list and making sure that it's a player, and then looking them up on the server and zapping them. But I haven't had time to do that yet. I will. So I'll just if I say zap.
You can say unsaved.
So I can say run Ermine zap main.
You got zip.
Oh, and I guess it doesn't matter what the heck I put here, but I see it just shocked myself.
What is the use of doing that? That's just gonna like make you die.
Oh yeah.
And then you lose everything you're carrying.
Version 2.0 will let him zap his friends.
Yeah. Eventually, it'll become more interesting.
Version 2.0 will save this stuff so that after he zapped himself, he can get it back.
There's not a heck of a lot of use
Free will be
in
good
zapping
for
myself.
controls than version 4 will be for enemies.
All right, now, then what I just implemented. All right, so that's all in this Ermine plugin. I have this command here, run Ermine, and it takes a module and a function and the arguments. Then it looks up the module and the function in the cache to see if we've already ran that function. We just pull out the result, and if we haven't run it, we actually run it and get the result. But
this is where you could alternatively do the unsaved.
Oh.
yeah, right here. So like I'm making sure that I get a function back, and then I apply it, and then I get to assume that that's an I/O action after I apply it, or what, and then I get unsafe right there.
So those prims are wrapping Java objects and handing them over to Ermine, because for the most part we can take, like we have this little runtime type that we carry around, like all the objects we're working with, and then prim can just be anything for it.
All right.
And we had funks.
So this next part is pretty fun. Run Ermine listener, which allows me to, given a module and some function that has to give me back a listener object, I then register that listener. If it gives me back something else then besides a listener, it's just going to blow up when we try to extract it as a listener. But I'll deal with that later. I have this module, block changer gold, which is something I use in a lot of the Scala examples that I did for building up my Scala plugins. And it just has one function called change, and this on-block damage is a function that I have in Minecraft.e that returns you a listener given a function from the block that got damaged, and then this event, which I'm not actually using here. Like the event has some additional information about what happened, like maybe the player who damaged the block. I'm not sure what else is on there. I don't care. And given that block, I'm just going to set its type to gold. So if I run this inside of Minecraft now, monsters around, I have to be careful because they'll kill me. So make sure. So I'm in creative mode. That's why they're not killing me. But I have to just set my game mode to survival. Now I can be killed by monsters, so I have to be careful. But now I can't kill blocks. But now, I can't paste in there, but I can paste into this terminal. So I'm going to register this listener. So I'm calling that register Ermine listener function that was in my Scala code with block changer gold as my Ermine module and the change. I'm dying.
You're on the typing. I think this might be the first PL talk where somebody has actually died during the presentation.
All right. All right. Yeah. I'm just going to call this change function. I'm just going to register this particular listener. All right.
All right.
So, bang! I registered it. Now, when I hit stuff, it changes to gold. And that's it. You see, like that was just like, you know, just this big. That's pretty cool. And I can drop other stuff in.
Call this minus touch enable.
Say what? Oh, I see. All right, let's
If you hit a monster, does it turn to gold?
Sadly, just blocks.
Only blocks. So it's on block damage. So I think like I should be able to. I don't know what happens if you register 2 block damage listeners. But I'm going to change this right now to expose diamond block as diamond. While the server's running. And I'm going to change block changer gold to just be diamond. And I'm going to re-register that listener.
Do you have to re-register? Has it
Yes.
just changed?
Yes, because
Yes.
it actually registered to the function, not to the name of the
It
function.
registered the old, it created a listener and registered that guy. Okay, so I'll do it again. It's going really slow.
Now you know what happens when you register to.
Okay, so I registered it. Let's but now there's two listeners registered. I don't know what will happen. I guess it just picks the last one.
Probably runs them both.
Or ran the, yeah.
It might run them in order. I don't know.
Given the amount of diamond around here, I presume you've done this before.
Well, I didn't accidentally. I changed all the trees to diamonds. Or,
Why did
You are a very strange god.
I don't know. I just forests and I just changed all the trees to diamonds, and then all their leaves died because they weren't next to wood. I do lots of fun stuff. I mean, I wrote a program to do it. I didn't actually go around. That would be crazy.
So why are there trees over there?
Well,
He did it in a box.
In a box. Like I picked 2 corners of the world, and I changed all the wood to diamond in that cube, and that was on the edge. So if you go over here, you can see it's on a line.
Oh.
Yeah, but it's a little bit hard to tell. But it happened in a cube. That was a long time ago. This has been my demo world for a long time. I have all sorts of crazy stuff in this world.
So where are all the woodland animals that live on that little patch of land?
They're going to be diamond that
Yeah.
Customer goes to gold.
So, I
They can explore the Diamond Hills over here.
Yes. There's a mountain that I changed all the grass to diamond and all the stone to gold and
Economy in this game.
other stuff to.
The economy will suffer, yes.
And here's that same mountain that I turned. Let me make this
Well,
bigger.
it's going to turn all the wheat to diamond.
I took that same mountain, this mountain over here. Before I changed it to diamond, I had moved it over here and I turned it upside down. I turned this whole town upside down too. I did a lot of stupid stuff.
So where did you write all
Wait,
these
is that a-
plugins, or can I go get them somewhere?
What's that?
Did you write all these plugins, or can I get stuff to do this?
Yeah, so all this stuff is open source, and you can get all of it on my GitHub. You can actually even get this Ermine stuff, except like right now there's custom build steps that I'm doing. You probably won't be able to figure out how to get it to run. Come on. But hopefully, soon, since I've only just started this, I'll have instructions on how to, how to run Ermine on your Minecraft server. There's tons of instructions on how to run on Scala on your Minecraft server. That's all pretty well documented. There's Scala docs and stuff too for all this stuff. So it's just on.
Read Ermine doc.
Yep.
That's here.
Do you expect many contributors to this Ermine code on GitHub?
I do not expect any. I've gotten none for the Scala code. I'm sure I'll get even less for the Ermine code.
Someone will take your code and they'll take it away from you, they'll delete it so you can't find it.
Yes.
That's the only way you can get less than none contributors.
Well,
See what happens.
all right. Any questions on this stuff? I don't know sort of fast, but
I want this thing to flip things upside down.
well, all right. I mean, I can do that. Oh, you just want to have that on your server?
Yeah.
Yeah. I have a world edit plugin that you can install, and that has a whole bunch of commands, and one of them is just flip X, Y, or something. I can't remember exactly, but just given your cube, it just flips it completely upside down.
You have like copy and paste and stuff too.
Yeah, I do have copy and paste and move.
I don't play Minecraft very much.
Yet. All right, so yeah, that's all the Ermine code that I have to show. I wish I had more, but
That's pretty impressive.
all right, thanks.
Thank you.
All right.
So I think, yeah, that's about all we've got. It's a neat toy. The code is available on GitHub. You can play around with it. It's on github.com/ermine-language. There was somebody, there was a user named Ermine. Unfortunately, we couldn't have it because somebody likes little weights too or something. So there's Ermine language. It has, like I said before, it has the new Haskell compiler that we're working on, and some headers for that. And then it has just kind of an info dump of ever so slightly lobotomized version of the old Scala Ermine compiler, and then it has a sketch of what like a core interpreter looks like in Scala that we're going to probably flesh out, improve.
It's probably going to change completely.
Yeah.
Yeah, it'll change a lot.
That-
What was it? You said there were Haskell projects that have launched since.
There was like
There's Cal and there's Frega.
yeah.
At least there may be more. Cal, C-A-L.
Yeah, so both of those are out there. They have different things that they're good at. That.
There's also data lotion.
So at one point in time, we didn't know what we were going to name the thing. Runar went off and wrote a little
Markov
chain naming thing. That what it would do is it would take like 50 or 60 programming language names, and then just started mashing them together. And so what we would do is we would just start up with like a random logo. And say, blah, data lotion, or I don't even remember some of the better ones.
Betalotica. Phaser Cam. There's LML.
And so when we actually picked Ermine, we were kind of sad because we lost these names. So about one time in 50, when you start up the REPL, it'll just randomly pick a name and show it to you as kind of like an homage to, there was an old Infocom game that used to do that they wanted to call Mage, and then they had to call it Spellbreaker, because marketing. And so 1 in 50 times you start Mage. So we kept so every once in a while, if you start up the Ermine REPL and you see Data Lotion or something crazy like that, you'll know why. No, you didn't. Oh, well, it's open source. Somebody can fix this. We have the source file.
It's out of the Scala version, but it's still in the Haskell version.
Woohoo! Yes, that's what it is, because the Haskell version has like get version or something like that, and it'll actually just get a string, but it doesn't say performs IO to get the random number to actually figure out whether or not it should give you the.
But wait, one of the randomly generated names happens to include like some portion of the language Miranda. Does the copyright notice? Because that would be awesome.
It's open source. Feel free to send us a patch.
Our Miranda is a trademark of Wizard Software, limited. Because people don't get the jokes normally, you know, which makes it more accessible.
What version JVM? What version JVM?
6 and 7.
Yeah, sounds right.
Yeah, it's not really
Yeah, we tie to whatever version of Scala we're on. What's the version of Scala that it builds? The existing one builds on?
210.
Yeah, so whatever Scala 210 will build on.
If your lower bound is 6, then
Well, it might run on lower versions, but I don't know. So,
anyways, that's our toy. I guess this is more of a structured session than we've been having of late. So that's all I got.